Hello, this is the third part on scheduling. Understand how resource limits can affect pod scheduling. So one thing we're going to do first real quick is look at carefully what happens when you supply resource requests and maybe don't supply a limit, and then maybe you supply a limit and not a request, right? And so what we're going to do is we're going to look at various combinations of supplying these values and see what the ultimate result is. So let me first go through the example here, which I apparently don't have open. Documents. This is 32. And I want to look at I believe this is the combinations, right? Okay, so there's a folder where I basically have various combinations of different pods. So the first example here is a sort of obvious mistaken example where I've made a request that is larger than the limit. That doesn't make any sense because the request is always supposed to be less than the limit, right? So that's one example to see what happens. Another example is I'm going to provide, the simple example is I'm going to provide no request or nothing. Okay, that's kind of my base case. I'm going to provide just a request of 100 millicPUs, right, and see what the resulting values are. And then I'm just going to provide a limit only of 150 millicPUs. And then the last example is I'm going to provide both request and limit. And I'm only going to just use CBU. Memory would follow along the same patterns, right? So let's first deploy this, and then we're going to inspect what the final result is. So in terms of what the actual request limits and requests are, and it's not as obvious as one thinks. In fact, I spent hours trying to figure out what these rules are. So Helm install dev, I'm in the wrong folder apparently. Wait, no, this is the right folder. Helm install dev combinations. So the first thing we're going to find out, the one obvious thing is one of the containers does not get built. That's the one that has the invalid combinations. So you get all. You will notice that I only have the pods. The one pod that had the backwards did not get created, right? It failed. Now, didn't even get past the API server. And then all these are running now. Now, how we can see, a quick way of looking at what all the values are, if you do kube control get nodes, describe nodes, you will actually see how these are all really running. And I'm going to look at I'm going to show them here, but I'm going to go to a graphic that I created to help illustrate all this because it's a little bit hard to follow here. So in this one here, you can see, for example, none has got 0 and 0, right? And then both, as you might expect, has, I got 100 for the request and 150 for the limit, which is what I asked for. And then there's a limit example, and then there's the request example, which is down here, right here. Request and a CPU limit, right? Now what I'm going to do here is instead of trying to parse this out, I did a nice graphic down here to sort of summarize. So what you're looking at here is, the visual here is a black dot represents an actual requested value, right? So when I made a request for 100, I get a black dot here, right? And then when I made a request for a limit, I get a black dot here on 150. And when I made a request for both, I get black dots. And as expected, when you specifically request something, the actual resultant value is what you asked for. So if I ask, so this case, the both is expected, right? Now, okay, so let's look at the open dots are the computed values or the values that it generates on its own. Like these values actually have values, and the system will pick them for you. Okay, so let's start with the none case. The none case, if you remember, it said 0 for both of them. So essentially what that means is the request gets 0, which means it's not really asking for any, no CPU usage, right? So it's not asking for anything. And there's a 0 that's listed for the limit, but in terms of the way it actually behaves, 0 really means infinity, right? Because the pod will actually always basically run. It doesn't get, like, the CPU is not being pegged, limited at all. So in the case of CPU, when it says 0 for a limit, it really actually means infinity. So that's that case right here where we looked at none. So this 0 is a little misleading because there essentially is no limit, but the limit is not 0. Like, this thing will not shut down at 0. It just will allow it to have actual usage. Okay, so the visual is when you give none, in this case, you get 0 and essentially infinity. Now the request, you ask for 100 millicPUs, and the actual request value again is 0. In this case, 0 means infinity. So it will allow this thing to grow, the memory to grow indefinitely. Now the one and then the bottom one's pretty clear. You ask for 100 for request and limit is 150, so that's what you get. The one that's less obvious here is if you ask for a limit of 150 but do not specify request, the behavior is that the request gets set to the same as the limit. So that's what this is representing here. And that's maybe a little non-intuitive there. Now the way that, okay, so that's sort of what actually happened, right? Just with nothing else special going on, just applying this, and this is what I get. So I through this and some other examples we'll look in a bit, I've come up with my interpretation of how this is working. So the first general rule is your request has to be less than or equal to limit. And that makes sense, right? Another thing is that we observe that when you basically have a limit and you don't have, and later on we're going to be able to set that limit, but without anything special going on, that limit is 0, which essentially means infinity. That's something we observed. And then, okay, in terms of the limit calculation, and I think I just said this actually, is that when there's nothing special going on, that's what this no default means. We'll talk about defaults later. Nothing special in place, if you don't supply a limit, you basically get the maximum, and the maximum in this case is infinity. So that's why we have infinity here, and that's why we have infinity here. Okay. Now in terms of the request, okay, it's a little bit more complicated. First of all, if you don't give a request and there's a limit already set, like a hard limit, the actual request value is set to limit, and that's what's illustrated here. So because I set a limit and I did not specify a request, I always get the limit as the value for request. Okay, and then this top scenario is where things get a little more complicated because the rules there's a lot of ifs, ands, or buts, right? In this case, if I have no request and no limit, right, what happens for this value? And the value in this case, when there is no other special stuff going on, no defaults, which we'll talk about, you basically get 0. Okay, so those are the starting rules that I'm going to have, and we're going to, as we add new concepts like defaults and whatnot, and maximums, these rules will build on these rules slightly. Okay, so I have a hard time remembering these rules, to be honest, but either way, this is visual representation is what actually happened, and at least I think the one that everything else was pretty much intuitive, except for this rule where the limit instead of being 0, it actually pushed all the way up against the limit. Okay, so the next thing we're going to talk about, and we're going to explore the same kind of graph here shortly, right? You can also, on a namespace basis, set up some min-max. Okay, that means, so for example, you may not want developers in a particular namespace to create pods that are like super huge and consume a lot of memory, right? So you can actually put instead of these unbounded essentially containers, right, that are pods that can just consume all sorts of RAM, in this case CPU, I want to hard limit it to saying the max is something and maybe a min, just to make sure that they actually are giving some valid minimum value, right? So so basically, yeah, so what we're going to look at here is what you can do is they're called, I don't know if I have, we'll see by example. A limit range is what we're talking about. You can create a limit range and you can do a number of things with it. And then what we're going to focus on right now is enforce minimum and maximum compute resources per pod or container in a namespace. Now, there's other things you can do. You can mess around with persistent volume claims, which I'm not going to talk about here. There's something about the ratio between requests and limits you can monkey with. I'm not going to talk about this one. We will talk about setting a default, though, but that'll be the next section. Okay. So the two things we're going to focus on is the default value for compute resources and a minimum maximum for compute resources, because this is kind of in line with what we've been talking about. Okay, so let's look at an example of a limit range applied that's applying a minimum maximum. So if I go into the code, so first thing I want to do is I want to get rid of this helm uninstall dev. Okay, and then I want to go into code and have a folder called min-max. Okay, so min-max, okay, templates, lots of examples here. Okay, so first of all, the min-max this is what it looks like. So this is the limit range. So the first thing I'm going to do is I'm going to create a limit range for the default namespace, right? And here the format looks like this. You say limits, then you give it a max, you give it, god dang it, max, and then I say 200 millicPUs for the max, and then I'm going to set a min at 50. Okay, so essentially now it says whenever anybody in this namespace, well, there's specific rules, but generally you're saying, look, you have to at least got 50 millicPUs for your minimum CPU, and you must have no more than 200 millicPUs for your max. But the rule's actually a bit more complicated, so we'll go through the examples, because you got to consider all the cases where you don't supply a request. What happens then, right? So what I'm then do is I go through a couple of, now that it's in place, I'm basically doing what I did earlier with all my examples of providing one and not the other, except for I also add two more examples just to make it fail. So the low pod example is I'm asking for a 400 millicPU request, and this is too low because the minimum is 50, so this one's going to end up rejecting, won't even try to get created. The high one, I'm asking for more resource than what it allows, and this is going to get rejected. So those are kind of the easy cases. Okay, the less easy cases are, and this is basically what we did earlier, right? So for none, I'm not going to request anything. What happens, right? If I ask for, let's see, the request, I'm going to request 100, right, which is in the range, but I don't have a limit. So now what happens, right? And then I'm going to ask for a limit, which is 150, which is in the range, but I didn't supply a request, right? And then finally, I'm going to supply both, and it's going to be a valid, right? 100 is going to be in the range, okay? Now, it's hard to keep all this in your head, right? So let me deploy this first, and then I have a graphic that we'll look at that will help us visualize what's happening. So let's see, kube control get all, make sure everything's cleaned out. It is. Helm install dev min max. Okay, so again, I'm not expecting you to keep all this in your head because I can barely keep it in my head. So you can see that there were some pods. Now, interesting enough, it only complained about one pod, high dev, but, so that must be another bug in Helm, because kube control get pods, you will notice that the low one is not here either. It's only got the four, so the four cases that I've supplied both, I've supplied none. So this error message only is reporting on one of them, but the low dev was also failed too. Okay, now let's look at a graphic though. So again, just for giggles, I'll look at it here real quick. Kube control, describe nodes. So where I got all the data, right, I can go to each, basically I had to write this all down. I can go to each one of these examples, right, and look at what the actual, for example, I didn't supply for none. I did not supply any min max, and somehow you notice that it has 200 for min and max. I didn't supply anything, and somehow I got 200 for both. So again, some of this, when you first looked at this all seemed almost random to me. But if you graph this thing, you start to see patterns. So, okay, so this is the graph we're going to look at here. So, what I'm going to say is that first of all, the rules we learned earlier still pertain. Okay, and I'm going to try to use these rules to predict what the final result was. So, this is the final result, but I'm going to tell you that these rules are valid still. So, I'll flip back and forth. So the first thing is there's a new rule, okay? And in this case, this is basically describing the top case. So this is the oddball case, that when you don't supply either. So when you don't supply either, but there is a maximum, but no default. So you haven't set, we haven't talked about defaults, but we have not set any defaults yet, but there is a maximum, right? Then the minimum, the request becomes the maximum. Okay, so that's a not obvious behavior, but that's what actually happens here. Again, I would have thought this minimum would have been down at 0 or something, but it pushes all the way up against the maximum. Okay, so I'm going to go through these, and I'm going to use the rules to kind of predict what happens, right? So if you recall, this case I have a maximum set at 200. That's what this black bar is here. Minimum's at 50, right? And in this case, I've set none, either one of them, right? And the first rule that comes into play is on the limit. If there's no default, which I have not talked about defaults, then and there is an actual maximum, the limit becomes the maximum, which is kind of what you'd expect, right? You're trying to keep this from, it will automatically apply the maximum for it. Okay, and then the other rule is this one. How does the limit get set? Well, that's this rule. In this case, I've got no request, and there's no hard limit set. So what happens then is I don't have a default set, which I haven't talked about it. So the request becomes the maximum. So that's why you have that one. Okay. Now the rest of these are a little bit easier to understand. So the rest of them are rules that we've already learned. So we specifically asked for a request of 100, right? So you get that, and then the limit, right? The rule that we saw just a minute ago. The maximum is this 200, so the limit becomes 200. Okay, so that's how that gets set. And how does this one get set? I actually set here a hard set a limit, right, at 150, and the rule earlier says whenever I hard set a limit, right, and there's no request, then the request value becomes the limit. So that's why this value pushed up against this one, okay? And then the bottom one's obvious because I asked for those, and those are within the range, and you get what you asked for. Okay, so I'm trying to illustrate the fact that the way this behaves is not super obvious, but these rules do apply. At least, and again, the way I figured these rules out was just by trial and error, okay? Now, there's another concept of defaults, which, and again, I guess if I was really careful, I would have done defaults and minimum maxims at the same time, which I didn't do, but I'm making some assumptions that, anyway, I guess for completeness I should have done that, but I didn't. So in this case, let me show you what I did here. You can, instead of setting minimum maximums, I'm going to set default values. right? That means if you don't supply something generally, these are the values you get as the general idea. Okay, so let's look at the example first. First I need to get rid of what's running. So helm, uninstall, dev. Okay, so let's look at the example here. Code. This is the example here is called appropriately default. Okay, and let's look at the template and let's look at okay, so give me a second. I'm trying to get myself here. Okay, so what we're looking at is the example limits, right? No. Yes, this is what I was looking for. I'm going to pause the video for a second. I'm distracted for a second. Hang on. Okay, I'm back. Okay, so this example is the default example. So I'm setting my limit range here with defaults, right? So the default limit, and the syntax is weird here, but this means the default limit for the CPU is 150, and the default request for the CPU is 100. It's just weird that this shouldn't, anyway, it's, the syntax just threw me off a little bit. But so this one, the top one is limit, and the bottom one is the request, okay? And then what I've done is I have, unsurprisingly, I've got scenarios where I've specified none, limit, the same thing I've been doing every time, supplying one or both of the limit or requests. And I have a graphic that will help illustrate it, right? So I don't want to spend too much time with that. So let's deploy this. And again, this is basically running the same scenarios, but with a default in place. Control, no. Helm install dev default. So they all deploy, or at least attempt to deploy, get all. I think they all should be running. So they all got something. You can do kube control, describe node, and you could do the same thing I did and look at each of these values and figuring out what they actually got, and then trying to figure out what the logic was. So instead of having to stare at that, the visual is going to help us. So before I look at the visual though, there are some new rules that we have to add to our list of rules. So we had the original set of rules, we added one scenario here, and then we're going to add in 2 more rules. And then we'll have a complete set of rules. So the new rule here is for calculating the limit, if you have not specified a limit, right, but there is a default, you get the default for your limit. So previously, if you looked at all that general rule, the related rule, it was limit no default, you got the maximum, right? But in this case, if there is a default, something else happens, you get the default for the limit, okay? And then the other rule has to do with this top scenario. When there's no request and no limit, you basically, the value you get for your request, right, is the default value, okay? Again, which was a little bit unexpected. I was expecting to push up against the limit, but it didn't. It actually defaulted to the default. Okay, so let's go through each of these scenarios, use the rules to make sure we understand it. So, god dang it. Okay, so first the none case, that's basically here, right? This rule, top rule, there was no limit set, so it goes to the default, right? And then for the request, there's no request or limit set, so the value is default. So that's pretty much that rule, okay? The next one is, how does this one work? This top value is this rule right here, right? Because there was no limit set, you basically get to default for your limit. In this case, the black dot is I actually asked for this number, asked for 50, so I got 50. Okay, that makes sense. This next rule is I asked for 200, right? something that was outside the default, right? I asked for 200 for the request for the limit. So the earlier rule was if I ever ask for a limit, then no matter what happens, the request always, if I ask for, right, I specify a limit, but I don't give a request. The value is always the limit. So that's why this dot pushed up against this one. And then this one's an obvious one. I ask for both of them, I get both of them. Right? I requested this, and I asked, and I requested this. Okay, so again, it's kind of complicated, but I think I distilled it down to some basic rules about how you might predict what the actual given if you don't do anything, and you don't request one of the requests or limits, or for the two other scenarios, which is when you have minimum and maximums, or when you have defaults, what the actual values. And I think the most surprising one out of this whole bunch, just so you know, is this pattern where the rule is if you ever hard code, the only thing I'll probably remember is if you ever hard code a limit, but do not specify a request, it basically pushes up against that limit, and the request becomes the same as the limit. It's probably the one, and everything else is mostly commonsensical, not entirely, but close. Okay, so then we're going to change gears a little bit. So far, we've been talking about like the behavior at the individual pod level, right? Putting constraints around the pods, but you can actually deal with the whole namespace as a whole. Right? So instead of, and you can put constraints around how many resources a group, maybe say a group of people use a namespace, how much the total number of, like say CPU units or CPU units are used across all the pods in that entire namespace. Okay, so that's what resource quotas do for us. Allows us on a per namespace basis put limits around the entire use of all. As opposed to earlier, we were talking about just on an individual pod what the limits were. Okay, so I think the easiest way of doing this is by example. Now, I guess before I forget though, there are other things you can do. I'm only going to talk about like CPU or memory constraints. You can also put constraints around number of objects of a certain type. Like you can say how many secrets they can set. Or so there's a section on limiting quantity, right? But we're going to focus on the total amount of compute resources used by, right? And so that's essentially what we're going to focus on here. So let's look at this example. This is the quotas example. So I've got to find it. Quotas templates. Okay, quota. Okay, so here I'm going to do, just to illustrate this again, I'm going to, what do I do? I'm saying for CPU, I'm only do CPU, I'm going to say the maximum amount of CPU you can request across all your pods is 300 millicPUs, right? So the way we've been using CPUs, it's like we were doing like 100 a piece, right? So, and anything more than that, it's not going to accept it, right? And then what it'll do is it'll actually give you API errors. It won't even let you, like an emission controller, it'll stop you from even making the request. And then I'm going to put a hard limit of no more than 450 millicPUs across all of the whole namespace. Now these are somewhat artificially low, but anyway, it's for illustration purposes. Okay, so there's that. And then I'm going to go through the example now. You got to think, well, what happens if they don't supply something, right? And in this case, I don't have any other, I'm just using the default case where I have no defaults, no minimum maximums, but I'm going to just throw out the none example, right? I'm going to do a limit, I'm going to do a request example, a limit example, right? And then a both example. Now you'll notice the both example fits. I'm asking for, well, again, this has to do with the total sum, but I didn't blow this out on this one. So what I'm going to do now is let me just deploy this, and I'm going to have a graph to help us understand what's going on. Okay, so again, this is Did I get rid of it? Dang it. Okay, I'm going to pause the video for a second while this kind of cleans itself up. Okay, I'm clean now. Okay, so let's see what happens here. Helm, install dev quotas. Again, the graphics will help us a lot here to understand what's going on. Okay, so you can already see it's complaining about at least one of the pods is not scheduling, saying the request dev, but in actuality, I think two of them failed. So let me think. I think I'm only going to see two here. So I've got limit in both. The none one didn't schedule, and so neither did the request one. Okay, so let's think about maybe why that could have happened. Okay, and again, and of course I don't have my, wait. Oh, I have a graphic that I'm missing. Let me pause the video. Wait, actually, no. The graphic is actually, let's look at the graphic is actually the one that we look at. The graphic we are actually happening is we were back to this scenario here where I've not specified, there's no defaults, no minimum maximums, I just let it go, right? So the reason why the top two did not even, weren't even to the point where they would even, they didn't get through the mission controller. These didn't even attempt to add these. And the reason why is because these right sides are essentially unbounded. So these are basically infinity. And there's no way if I sum up, I mean, the moment I try to schedule one of these, they're already going to exceed the limit of like 450, I think I said. So these two can never be scheduled because they basically have no bounds on their limits. And I said across the whole namespace, I only have 450. So there's no way these could work. Now these did work, right? Because I actually gave a limit, hard limit on one case at 150, and I gave a hard limit of 150 for this case, right? Now, one thing we can do, so if I look at kube control, one thing you can do is you can say describe limit, I think. No, quota. Okay, so again, this is a namespace. I'm looking at the quota, and you can see, okay, so here's what I'm going to look at. Here's what I'm going to focus on. So for the CPU, I've got a hard limit on the, this number here, 450 was a hard limit on the number CPU, and 300 was for the request. And then it's now telling me that I've already used up 300 of the 450 for my limits and 250 for the request. And we can see that kind of visually from this diagram. So let's look at the request. It's 250, right? So how did I get to 250? So for the requests, the only two that matter were the bottom ones, right? So one request was, I manually set to 100. So that's where the 100 came from. But the other one was computed at 150. 150 plus 100 is 250. So it's the sum of these two numbers here that end up being the 250. And then the way I got the 300 for the limit was it added up these two. 150 plus 150 is 300. That's why I used up 300 of my limit for CPU. Okay, so again, the broad idea here is by using these resource quotas, we can now keep basically, you're going to disallow certain patterns, like things that just blow out the number of limits, right? Or you're going to basically not allow them to use more than some total amount of each of these requests and limits, right? So it's another way. It's again, the big picture was the first example of limit range min maxes. That was more about controlling individual pods to make sure they don't blow themselves up. What we just introduced with the quotas is making sure that the sum of all the pods in the namespace don't blow up and have a large amount of usage. Okay, and that's essentially the end for this video.